I'm going to show you the selection sort algorithm. Selection sort algorithm, by the way, works whether it's a linked list like we have here, or it also works with arrays. It's the same basic algorithm. Obviously, the difference is that here, when I'm talking about which node, we're talking about the address of the node, whereas with an array, it would be the index value or an integer. Okay. All right. So the basic idea with selection sort is that we're going to select the smallest value in our list, and we're just going to take that smallest value and move it up to the front of the list. And then the next step is to, okay, that one's sorted, let's look at all the rest of the values and select the smallest out of the rest of the values, move that in, swap that into to the front of that part of the list. Okay, so that's the basic idea. So we need to be pointing to the first value. Obviously that's going to be head to begin with, but we're not going to move head throughout the rest of the list, so we're going to make a temporary pointer here, I, and I want to go ahead and look at all the values from I to the end of my list and find the smallest value. As you can see, we have 3 and 3 here are both the smallest value of all of these values here. I'm going to go ahead and always just make sure I work with the first one that I find. It should work either way, but I'm going to be working with the first one that I find. Okay, so we're going to go through this list, and you should be able to, I assume you know how to find the smallest value in a list of values. It really is, again, the same as you did with arrays or vectors. It's just that instead of index values, you work with pointers. Okay, so once we've gone through this entire list, finding the smallest value, not the smallest value, but the location of the smallest value is what I really need, not the smallest value. I need to know where it is. Okay, so once I found the smallest value here in this entire list, I have a pointer to that, I have a pointer to the beginning here, and I'm just going to swap these values. Now, if I was working, I'm working with integers here inside here, so we're just going to swap the integers. But if the values, the objects that I'm storing in my linked list were objects that have multiple data fields, right? So it's actually storing a whole bunch of data in each object, then it would be more efficient to actually swap the nodes rather than just swap the contents of the nodes. But for integers, it's just as efficient to swap the values. Keeps it simple for our assignment, so let's just swap the values, okay? So we're going to just swap 3 and 5 here. So again, I have a pointer to the node that's containing the smallest value starting from I going to the end, and of course I have the starting node. So I just swap these two values. In fact, the swap function in the algorithm library will work as long as you provide the correct arguments to that swap function. You could make your own as well, or just swap them. Oops. This is 3 and 5 goes to here. Okay, so that swapped the 5 and the 3 so that the 3 moved up to the front, and notice that now at this point this node is sorted. It has the smallest value in my list, okay? And so now the next step is we just move I over, right? So if this was an array, we'd be incrementing I. It's a linked list, so we're hopping I over, moving I over so it points to the next node, okay? And so now we start from here, start over again. Starting from here, let's find the smallest value from I to the end of my list. In this case, this is the location of that smallest value. Okay, and so now I just swap the value in node I here with node min here. Okay, so the 3 moves up and the 6 moves over. So we just swap those two values, and notice that now the first two nodes up to I are sorted. We hop I over to the next node. Okay, and we find the smallest value in the rest of this list, and hopefully you can see that this is the smallest value. So min didn't move very far at all, right? So min is going to be right here. You can either swap or not swap depending on how you want to do that. So it's fine if you just swap it with itself. It's not any inefficient or anything like that. So we go ahead and we're done with that. We move I over. Okay, we find the smallest value starting from I going to the end of the list. So min now points to this node here. We swap the values at I and min. Okay, and we move I over, we hop I over, start over. Well, do we start over again here, right? At this point, do I need to find the smallest value after I? Well, there are no other nodes after I, so I actually stop right here. I don't need to do that whole extra iteration. So in other words, I can stop when I is pointing to tail, right? When I and tail have the same address, I'm done. Okay, and notice that we now have a sorted list, sorted in ascending order. All right, good luck with your assignment.